Hi, I am Ankit and welcome to TriboTech. In this video, we will learn about different perturbation-based explainer tools like GNNExplainer, PGExplainer, GraphMask, and SubgraphX. So first, we will have a brief recap about perturbation-based explainers, and then we will see each tool one by one. So these tools are basically invented by different researchers across the world. So perturbation-based explainers basically involve removing or masking of different parts of the graph, like edges or node features, or maybe both. And we measure the change in prediction caused by masking of those parts, and we compare it with the original prediction with the original graph as input. And we use this information to basically determine which are the important substructures in the graph. So you can have a look at how the perturbation-based explainers are basically integrated in the GNN pipeline. So different explainer tools, which we are going to cover in this video, basically differ in three aspects with each other. And these are: number one, the type of mask which they use. For example, some explainer may be using soft mask while the other may be using discrete mask, or there could be some other third type of mask which they would be using. Second aspect is the algorithm which they use to generate the mask. Now you will understand this in the coming slides, what I'm exactly talking about. What are the algorithms to generate mask? For example, they could be optimization algorithms, they could be using neural networks, or they could be search algorithms also. And the third aspect in which these explainers differ from each other is the ultimate objective of your problem. For example, you could be interested in considering edges only. On the other hand, you could be interested in only node features, or there could be some other third problem. So this is also one aspect in which these tools basically differ, which is the ultimate objective of your problem. So let's now discuss these explainers one by one. So we will start with GNN explainer, which we have also covered in our previous videos. So this explainer basically uses soft masks, which are real values between 0 and 1. So it is not strict or binary, but it is soft. Uh, and these soft masks are basically used to learn importance patterns for both edges and node features. So GNN explainer is interested in both edges and node features. So these are the important features of GNN explainer which you should keep in your mind, because in the coming slides we will discuss other explainers, and then you can compare them with GNN explainer. The algorithm that GNN explainer uses is gradient-based optimization. So the mask values, the soft masks, are basically learned by minimizing a loss function, as you can see in this picture over here. So the use case of GNN explainer is mostly in single instance explanations, because they learn a new mask for each graph separately, right? So they are best or naturally suited for single instance application explanations. Right? And the other use case of GNN explainer is when both node and edge explanations are required. So if you're interested in both node and edge explanations, so it's better to go with GNN explainer as your tool. And their examples are molecular graphs, citation networks, and further they can be applied in other graph machine learning problems very well if they belong to these use cases, right? So who invented GNN Explainer? So basically this tool is invented by researchers from Department of Computer Science at Stanford University, and they are also part of Robust.ai, and they published it in the form of a research paper titled GNN Explainer Generating Explanations for Graph Neural Networks in 2019. The paper is on your screen. Now coming to PGExplainer. So PGExplainer basically stands for Parameterized GNN Explainer. Now what happens in PGExplainer is the explanation is produced by a parameterized neural network. So this is something which makes it different from GNN Explainer. So instead of learning a new mask for each graph separately, which was the case in GNN Explainer, in PGExplainer, we learn how to explain using a neural network, and we can use that knowledge to explain all the graphs in your uh, training pipeline. So basically what we learn by explaining any one particular graph like this can be used to explain other graphs in the pipeline as well. And this is done on purpose. So what is the intention behind doing this? You will see in the next slide. So PGExplainer basically uses approximated discrete mask to provide explanations. And here we are interested in only edges and not node features like GNN Explainer, right? And the algorithm which is used to generate masks is a neural network, which I already told. And this neural network is trained using gradient descent. Now you may be wondering, what are approximated discrete masks? So they are very special masks. You can say best of both worlds. So they behave like a discrete mask during explanation. During explanation, they say that this edge is important or this edge is not important. There is no partially important edges there. So the explanation is very clear. But these masks behaves like a soft mask during training, which helps in computing the gradients and therefore helps the smooth learning of the mask values during training. So why we don't use soft mask in PGExplainer? Because the idea behind PGExplainer is to produce clear and reusable explanations. And that's why we want soft mask only during training. And so we are using approximated discrete mask in this explainer. And also PGExplainer is designed for clear reusable explanations, especially at scale. So our interest is to explain the whole model here, right? So not just single instance, but multi-instance, right? So the other thing about PGExplainer is that we are only interested in edges and not node features. Now, the one reason behind this is that edges are more structurally meaningful because they control how information is flowing in your GNN model. Because if you remove an edge, it directly blocks message passing. So edges are easier to interpret and they are more structurally meaningful than node features. The other reason is that in node features, the number of node features across all nodes and across many graphs is too much. So it would be computationally very expensive for an explainer like PGExplainer, which is operating on a model basis, to explain all the node features. And node features are also harder to generalize and harder to interpret compared to edges. You can understand this by, let's say, you learn the mask values of node features in one particular graph using PGExplainer. So these learnings you cannot easily apply in another graph using PGExplainer. So it's hard to learn, but edges are comparatively easier to learn using neural networks. So this is the idea. So the use cases of PGExplainer are, of course, large data sets, as I already told you that they are designed to work on a scale or when fast and reusable explanations are desired. Who invented PGExplainer? So basically this tool is invented by researchers from Pennsylvania State University and NetLabs America, and they published this tool in the form of a research paper titled PGExplainer Parameterized Explainer for Graph Neural Networks in 2020. So another perturbation-based explanation tool is GraphMask. In GraphMask, we are interested in each GNN layer. I repeat, each GNN layer. This is important. So basically, we use discrete masks here to explain the importance of edges. So basically what happens in a graph mask is that the explanation is attached in each layer, and it is designed like that only. So it uses discrete mask to explain the importance of edges in each GNN layer. So basically here we are interested in understanding that how the information is flowing layer by layer in GNN model. Or there could be other use cases of GraphMask as well. Like if you are interested in debugging your model internally, then also this is a great tool. And if your objective is research and model analysis, this is again a very suitable tool. Now, why it uses discrete mask? Because it is designed to give faithful explanations for each GNN layer. It aims to tell you that this edge was active or this edge was inactive. So there's no scope for partial edges again here because that doesn't make sense structurally, right? Now, GraphMask is similar with PGExplainer in many ways, like they both use neural networks and they both predict edges and not node features. But the difference between the two is that PGExplainer is interested in the whole model globally, whereas GraphMask is interested in each layer. So it's more like a diagnostic tool. Right? Who invented GraphMask? So it is invented by the researchers from the University of Amsterdam and Edinburgh, and they published this in the form of a research paper titled Interpreting Graph Neural Networks for NLP with Differentiable Edge Masking in 2020. The paper is on your screen. So another perturbation-based explainer tool is SubgraphX. Now this tool uses a different approach. The objective is to identify important subgraphs within the graph, but it uses a search-based approach and it uses a technique called Monte Carlo tree search technique to search for the nodes and it trim the nodes away to basically arrive at the important subgraphs. So this is a different approach which we have not seen so far in the other explainer tools. So we will not go into the details of Monte Carlo research techniques. The only thing you should know at this point is that it is a smart search algorithm which is also used in chess engines and AlphaGo. and it balances exploring new options and exploiting good ones. So it's a search-based technique, and this visual basically shows the node trimming technique, which I discuss right now, to arrive at the important subgraphs. So the use cases for SubgraphX is when you are interested in node level explanations, or when you are interested in structural motifs. So that's why it is commonly used in uh, chemistry and biology, where molecular graphs are more involved. And since it is a search-based technique, so when your interest is more in explanation quality rather than the speed, then SubgraphX is a better tool for you. Who invented subgraphs? So this was invented by researchers from Texas A&M University, University of Science and Technology of China, and West China Hospital. And the paper on explainability of graph neural networks via subgraph explorations is on your screen. So after knowing about multiple explainer tools, uh, the question which naturally comes to our mind is that which explainer tool is the best? And if you followed me correctly, then you already know the answer. And the answer is that there is no single best explainer tool. And it depends on what your interest is, whether your interest is in explanations on a scale, or whether you want good speed with explanations, or you want good depth. So it ultimately boils down to what your interest is, what you are looking for. For example, if you are looking for simple and intuitive explanations, then GNNExplainer is your tool. If you are looking for fast and scalable explanations, then you should go for PGExplainer. If you are interested in layer-wise understanding of your model, then you should go for GraphMask. And if you are interested in high quality subgraph explanations, then SubgraphX is something you should go for. So this is it in this video. We discussed different types of explainer tools, perturbation-based explainer tools like GNNExplainer, PGExplainer, GraphMask, and SubgraphX. And these tools are basically invented by researchers from different parts of the world. So we discussed the use cases of each type of explainer tool, and we also saw that there is no single best explainer tool, and it all depends on the scenario or the actual problem which you are dealing with. So I hope this video helps you as to which explainer tool you want to go with in your own graph machine learning problems in future. If you have any questions, feel free to leave comments. Thank you so much for watching. Wish you all the best.